Make sure to include your name and the date on your report. For your solubility, in the table, make sure that you're adding the number that you have in your liquid and in your solid. So you're going to have two containers, one with your unknown liquid, one with your unknown solid. Both containers, they have the same number, so make sure that you copy the number from the label right here. Okay, you should have the same number for both. To fill your table here, you're looking at your liquid and your solid, and you're adding your liquid and your solid into your test tubes with the solvents. And you're looking at if they're soluble, insoluble, or if they're partially soluble. So you're completing the table just with SI or SP depending on your observations. For the next part, you're looking at the density of your liquid. You have the mass of an empty beaker, and your beaker was dry and clean. So you have the mass of your liquid, the mass of your beaker empty. You're copying that number. Make sure that you include the units. Then you're adding into that beaker 10 milliliters of your unknown liquid. And it's 10 milliliters because you're using your pipette, and the pipette measures 10 milliliters. So you have to make sure that you're using your pipette in a proper way, and that the volume that you're taking is the volume that the pipette allows you to measure. So you're transferring those 10 milliliters into the beaker that you have in your mass balance. And now you're going to have a new mass. Is the mass of your beaker with your liquid inside. So you can calculate the mass of your liquid, which is the difference between the mass of your beaker with the liquid minus the mass of your empty beaker. That will give you the mass of your liquid. The volume of the liquid you already have, because that's the volume that your pipette is measuring. So that will be your 10 milliliters. And you can calculate the density, that's number 5, because density is the mass of your liquid divided by the volume of your liquid. Make sure that you show your calculations here and that you include the units. That's for the density of your liquid. Now for the solid, this part is where you're estimating the density of the solid, if it's floating or if it sinks in a specific solvent. So remember, you're using the test tubes where your solid is insoluble, and you're looking at the density of your solvent, cyclohexane, water, or ethanol, and you're comparing that number with the density of your solid depending on what's happening to the solid. If the solid floats, it means that the density is lower than the density of that specific solvent. If the solid sinks, it means that the density for your solid is higher or greater than the density of your specific solvent. If the solid part of your solid remains floating on top of your liquid and part of it goes to the bottom, so your solid is divided, it means that the density of that specific solid is very close to the density of the solvent that you have in that test tube. Make sure that you include the units here too. So for your estimation, you should have greater than a specific value, which is the specific value for the density of the solvent, or less than specific value for the density of that solvent. For the melting point, you're looking at a range. You have your solid in your capillary tube, and you start heating up your solid, and you're going to be looking at your solid as soon as it starts melting. You will see like some bubbles of liquid forming in your capillary tube. When that happens, you need to look at the temperature. And you have to keep looking at your capillary tube until all of the solid melts. So you will go from your solid to some solid with liquid until you have only liquid in your capillary tube. So the range here, it means that you have an initial temperature where it's when the solid starts melting and you have some solid and some liquid, and then you have a final temperature that one is when you only have liquid in your capillary tube. So that's why you have a range. The experimental value here will be the average between these two numbers, okay? The ones that you have for your range. So I'm going to make a note here. Let's say that your solid starts melting at 60 Celsius and you have all liquid when the temperature is 70. That's your range, from 60 to 70. So in your range you have two temperatures, when it starts melting and then when you have only liquid. The experimental value is the average of these two temperatures, okay? 60 plus 70 divided by 2, that's going to give you the experimental value. For that example, it should be 65. Okay? So your range, it's when it starts melting until it melts entirely. Experimental value is the average for those two measurements, the ones that you have in the range. So you have to do this twice. So you have one range for your first determination, a second range for the second determination. Experimental value, you will get two again. The first one is the one that you have for your first range, or the range in your first determination. The second one, it will be the experimental value or the average that you have for your second determination or that range. The final average that you have here, the last thing in your table, that's your experimental value in your first determination plus the experimental value in the second determination, and then that's divided by 2, and that's how you get this average here. Boiling point, you're going to look at the boiling point of your liquid 2 times and the average for that one. Boiling point, BP, first determination plus boiling point, the second determination, divided by 2, that's your average. This one. To determine which liquid and which solid you have to look at the table that you have in page 77. So you're going to compare your results, and based on your comparison, you're going to actually identify your solid and your liquid. So when you're identifying your liquid, look, the solubility is the least one, or the least accurate one. You're looking at your liquid, how it dissolves in other liquids. So sometimes it's very hard for you to identify it is actually partially soluble or insoluble. The best test that you can use to identify your liquid should be the density. If you're actually determining the correct volume using the pipette, the density should give you a number that is very close to the ones that you have in the table. The second one should be the boiling point. If you're actually looking at the temperatures and you're determining the correct boiling point, you should get a number that is close to the one that you have in the table. For your solids, you're doing something similar. You're comparing your numbers to the ones that you have in that table on page 77. So for the solid, remember, you don't have an actual value for the density of your solid. you have an estimate, and that estimate is useful. Okay? So, and you have your melting point for the solid, boiling point for the liquid. So looking at your numbers and comparing with the ones that you have in the table, you should be able to identify which solid and which liquid you have. In your page 81, not 83, in page 81, at the end of the page, where you have your report, at the end of your page, write down using that table which liquid you think it's yours. So you're going to look at the table, and based on your density, boiling point, and solubility, you're going to identify like a possible liquid: methanol, ethanol, using the table, acetone, whatever it is. So write it down, liquid and the specific liquid that you think you have. And then do the same thing for the solid. Put a small note in the corner of your paper, the solid, and which solid you have.